Hello and welcome to another digital design class. In the previous classes, we started the sequential logic circuits. We started with the latches, SR latch, and so on, D latch, and so on. And then we continued with the flip-flops. The main difference between a flip-flop and a latch is that the flip-flop is edge triggered and a latch is level triggered. So using a D latch, we can build a D flip-flop. And from that, we can also, using the D flip-flop, we can build a JK flip-flop and a T flip-flop as well. Now, we also spoke about the different characteristics of different flip-flops, and we solved some problems using their truth table. We also did an analysis of clocked sequential circuits and how we analyze them using a transition table. And we solved the problem for this as well. Now, today we're going to continue with the transition table, but use another approach. This approach is called, what we mainly use is called the state diagram. And the state diagram is the easier way to actually solve these type of problems. And actually, it simplifies the transition table. So let's start with the same example that we had before and continue with that. I want to go first to the example that we solved last week. So the example that we had last week was we had two D flip-flops, and the inputs were connected using, for the first one, OR and two AND gates. The B flip-flop the input was connected to an AND gate, and one of the inputs of the AND gate was connected to A, and we had a Y, and we had the input of X, and the other two inputs were A and B at the previous time. And we learned that we can write the state table or the transition table by putting in the present state, the next state, and the outputs. And using this table, we can also write the Boolean function for this as well. Now, there's also a different way to represent this. It's called the state diagram. So what does a state diagram look like? A state diagrams are circles, and they have arrows connecting those circles together. Those circles represents the variables itself, the outputs, and A and B for the flip-flops. And the arrow represents the input, output. And I will show you how it works. So for example, imagine my state or the present state or the output, A and B are 0, 0. Okay. And I want to go to next state, which is again 0, 0. So I'm going from the present state, what I am right now. Let me pick. From 0, 0, I want to go to 0, 0. Okay. So if I want to go from 0, 0 to again 0, 0, what is my input? My input would be 0. And my output would be also 0. So I'm going to have 0, 0 to go from 0 to 0, 0, 0. Now I want to go from 0, 0 to 0, 1. So here, if I want to go from 0, 0 to 0, 0, X is 0 and Y is 0. So my input is 0, my output is 0. Now, what if I want to go from 0, 0 to 0, 1? So if I want to go to 0, 1, I will draw another circle and put 0, 1 on it. And I'm going to draw an arrow. And I'm going from 0, 0. This time, let me draw it with a different color. I'm going from 0, 0 this time to 0, 1. Now, if I want to go from 0, 0 to 0, 1, what is X? X is 1. And what is Y? For X, 1, Y is 0. So it's going to be 1. The input was going to be 1, and the output would be 0. So I did on the right. You can do it on the left or down. Doesn't matter. Both of them are the same. So my x is 1. Again, if I want to go from 0, 0 to 0, 1, x is 1. And for x1, what is y? The output is 0. Okay. Again, x is my input. Y is my other output. Now, for the next stage, I want to go from 0, 0, 1 to 0, 0. So I'm going from 0, 1 to 0, 0. I'm going back. If I want to go from 0, 1 to 0, 0, what is my input? The input is 0, x is 0. And what is the output when x is 0? 1. So this would be 0, 1. Okay. Now, for the next stage, I'm going from 0, 1 to 1, 1. So I'm going from 0, 1 to 1, 1. If I click, I think the next one will go so 0. Now for the next one, I'm going from 0, 1 to 1, 1. If I want to go from 0, 1 to 1, 1, what is my x or the input? 1. And what is my output when x is 1? 0. So if I want to go from 0, 1 to 1, 1, x is 0 and y is what? I'm sorry, x is 1 and y is 0. By the way, this is my x here and this is my y, input and out. Now I'm going from 1, 1 to 1, 0. If I want to go from 1, 1, again, I'm going to add another one here, 1, 0. Let's draw this one as well. Or let's go from 1, 1, this time 1, 0, 1, 1 to 0, 0. Let's start with this one. So I'm going from 1, 1, because it's this one now. I'm at this point and I want to go back to 0, 0. So if I want to go from 1, 1 to 0, 0, what is my x? 0. And what is my y? So when x is 0, what is y? 1. So it's going to be 0, 1. Okay. So the next one is going to go from 1, 1 to 0, 0. Now I can also add the 1, 0. So I can go from 1, 1 to 1, 0 as well. If I want to go from 1, 1 to 1, 0, I'm going to draw another one, 1, 0. What is my x? And what is my y? Y. X is 0 and y is. So x is 1 and y is 0. Now I can also from here, I can go from 1, 0 to 0, 0. And I can go from 1, 0 to 1, 0. So if I want to go to 1, 0 to 1, from 1, 0 to 1, 0, x is 1 and y is 0. Thank you. And if I want to go from 1, 0 to 0, 0, x is 0 and y is 1. Now I have the state diagram. Okay, so using the table, we can write the state diagram, which is much easier to interpret, and I would explain more about this. Or we can go from diagram to the table as well. So it's like a K-map, but for flip-flops to be able to better represent them and simplify them. Now let's solve another problem. Example. So for example, a D flip-flop is connected to an XOR gate, and the input is connected to another XOR gate. And one of the inputs of that XOR gate is the output A. And the output here for the next state, AT plus 1 or DA, is going to be A XOR with X, XOR with Y. Now, if I write the truth table for this, let's complete this together. I'm going to give you some time to think on the first row. So if initially A was 0, and X is 0 and Y is 0, what would the output be? Okay, let me solve this first one to fresh your memory, and then we could go there. So for an XOR, if both of them are the same, the output would be what? 0. So 0, 0 gives us 0. And now this one is 0. This one would be 0. Therefore, DA, or the next state, would be what? 0. So 0, 0, 0 gives us 0. Now for the next one. A is 0. Now X is 0, but Y has changed to 1. What would the next state of A be, or DA be? Tyler, what was it? 1? Yes, correct, it's 1. So 0 and 1 gives us 1 here, and again 0 and 1 gives us 1. So it's going to be 1, and the 1 shows in the up. Now imagine if A is 0, now X is 1 and Y is 0. Again, what happens? It's going to be another 1. Now, if the present state is 0, X is 1 and Y is 1, it's going to be 0. So this is going to be 0, and 0 gives us 0. So this would be 0. Now, what if the present state A is 1 and X and Y are 0? What is it? Yes, perfect. Thank you. It's going to be 1 because 1 and 0 gives us 1. What if A is 1, X is 0, and Y is 1? X is 0, A is 1, and A is 1. 0. So this is 1. This is 0 and 1. 1, 1 gives us 0. Thank you. And the next one, A is 1, X and Y are 1 and 0. Again, gives us what? 0. And the last one, if all of them are 1, 1 and 1 gives us 0, and 1 and 0 gives us 1. So it's going to be 1. Now let's draw the state diagram. The next states, or the outputs, technically, we have 0, 1. So I would have 2 circles. One circle is 1. The other one is 0. And I'm going from 0 to 0. So my first arrow is going to be, I'm going from 0 back to 0. What is my inputs? 0 and 0. So I'm going from 0 to 0. And what are my inputs? Are 0 and 0. Are these my only inputs? Yes. And what are the other inputs that we can find here? So here I'm going from 0 to 0. Can you see anywhere else in this table that I'm going from 0 to 0? Here again, I'm going from 0 to 0. Yes. So I have 2 possible paths from 0 to 0. And for the other one, what are the inputs? 1 and 1. So I can go from 0 to 0 using 2 paths. One 0 and 0 or 1 and 1. And we put a comma between them, okay? Now I want to go from 0 to 1. If I want to go from 0 to 1, what my inputs are? What are my inputs? It's going to be 0, 1, and 1, 0. Okay. So it's going to be 0, 1, and 1, 0. Now imagine I'm at point 1 in the circle 1. What are my paths? I can go from 1 to 1 or 1 to 0. So if I want to go from 1 to 1, what are my inputs? Yes, it's going to be 0, 0, and the other one 1, 1. So 0, 0, and 1, 1 gives me again, goes from 1 to 1. Again, 1 to 1 and 1 to 1. Now, if I want to go from 1 to 0, what are my paths? And 1, 0. So this is going to be my state diagram. Okay. So this is going to be your next quiz. This is also for the online students as well. And I want you to do this at home. I want you to build a T flip-flop just using this SR latch and NOR gates. So we want to design a T flip-flop using SR latches. Okay. The reason I want you to think on this and go home and solve it is because this may be one of your questions on an upcoming exam, okay? Or something very similar to this. Now that we learned about state diagrams, let's start with the analysis of clocked sequential circuits. For this, we have this example, 2 JK flip-flops, and you can see that they are the way they are connected. The first K is connected to an AND gate, one of the inputs to the NOT gate, and they share an input with its J and with the output of the second one, B. And the second one has the input of an XOR gate connected to the output A and input X. And both of them are synchronized with the same clock, as you can see. Now here, JA is going to be B and KA is going to be equal to BX prime, as you can see. Now JB is going to be X prime. Why? Because it's again connected with the NOT gate to X. So it's going to be X prime. And KB, because it's connected to this XOR, it's going to be XOR of this A and the X. So it's going to be A XOR with X. And if I want to write the next state, AT plus 1, which is DA, it's going to be JA Q prime A plus Q prime A QA. Where did we get this? We got it from the JK flip-flop equation. The JK flip-flop equation was JQ plus K prime, JQ prime plus K prime Q. Now we will replace JA with the ones that we already had and Q prime. So when we replace them in K prime and Q, we get to A prime B plus AB prime plus AX. We do the same thing for BT plus 1. Again, it's going to be J of B Q prime B plus K prime of B QB, which is B prime X prime plus ABX plus A prime BX prime. One thing that I want you to do is when you get home, I want you to deeply think on this because it may seem confusing at first. you need to go through it 2 or 3 times to fully understand it. So take your time to understand each of these equations. How did we get AT plus 1 and BT plus 1? Okay. Again, we already know JA is B, so we will replace JA with B, and Q prime, for example, here is going to be equal to B. So this is the way that we get this. Again, JA is equal to B, and the same thing we can find for Q prime A and so on. And K prime of A here, if KA is BX prime, then K prime of would be the inverter of that, okay, and so on. And when we simplify it, we get to this equation. And the same thing for BT plus 1. Now, we would draw the truth table for this, and after that, we would start with the state diagram. So that D flip-flop was an easy one. This one is a little more complicated. Now, the example here we have is the present state A and B and the input X. We're going to get to the next state, A and B, and the flip-flop inputs, JA, KA, and JB and KB. Now, just for a reminder, I want to go back for a second to the JK flip-flop, so you can look at what happens in a JK flip-flop. So in a JK flip-flop, if J and K, you can write this down, are both 0, then we would have no change. If J is 0 and K is 1, we're going to have a reset. In other words, the output would be 0, becomes 0. If J is 1 and K is 0, we're going to have a set, or the output would be 1. And if J and K are both 1, we're going to have a toggle. In other words, the output would be inverted. Okay, just take a look at this, and if you want to take a note, you can do that quickly. So again, JK0, no changes. J0, K1, reset. J1, K0, set, and 1, 1 would be toggle. Now, let's go back to the problem. Okay. So for the first line, if A and B are 0, 0, so if A is 0, then the input of this XOR would also be 0. And if B is 0, this input would be 0. So no matter what the other input of the AND gate is, the output of the AND would be 0. Now, where is J connected to? J is connected directly to B. So J and K are both 0. If J and K are both 0, what would the next state of A and B be? AB for A. Because J and K are both 0, it's going to be the previous state of A. And what was the previous state? 0. So A would be again what? 0. Now let's find B, or JB in other words, to find B. So if A is 0, this is 0, X is what? 1. 1, 0 gives us what? On an XOR. Gives us 1. And what is J? J is directly connected, so it's going to be 0, 1. When J is 0 and K is 1, would it be reset or set? Reset. And B is what when it's reset? It's going to be equal to 0. So JAKA was 0, 0. JBKB was 1, 0. Again, this was, sorry, this is 1. And then from these, we're going to have, oh, I did a small mistake here. Yeah, it's going to be 0, 1 for JB. So again, this is 0, this is 1, so J is 1. I did a small mistake. I thought X was 0, 1, and then becomes 0. So if this is 0 and A is 0, this gives us also 0. So it's 1, 0, not 0, 1. And when it's 1, 0, it's set. And when it's set, the output would be 1. Okay. Now let's solve it for the next scenario. A and B are both 0 again. So this is 0, 0, but x is 1. So if x is 1, x prime would be 0. This is 1. This is 0. 1 and 0 gives us what? 1. So KB would be 1. What is JB? What is JB connected to? 0. What is JA connected to? JA is connected to B or 0. Thank you. And what is KA connected to? To an AND gate, and one of the AND gate outputs is 0. So we don't care about the other one, and the other one is actually 0. So J and K are 0, 0. So if it's 0, 0, it's gonna, and JB was 0, 1. Yes. 0 and KB was 1. Now, if JA and KA are 0 and 0, it means A would remain its previous state, which is gonna be what? 0. And what happens to B? Yes. So it's going to be 0, 0, 0, 1, as mentioned. And this is going to be 0 and 0. Okay. Now I want you to solve the next one. And the first person to solve the next line gets extra bonus points for their next exam. So for the next one, A is 0, B is 1 for the current state or the present state. And X is 0. Okay, what is the next one? What is JA and KA? Okay, and what is JB and KB? Thank you. What is A and B? 1 and 1. Perfect, great. Now, what about the next one? So I want you to write down the table and think about all the rest, and then I will go through it. I'll give you like 7 or 8 minutes to complete the rest. It's going to be a good exercise, so. Okay, did you all finish it or you need more time? More time? Okay. Okay, did you all solve it? Yeah. Okay. So if the present states A and B are 0, 1, and X is 1, then JA and KA would be 1, 0, JB and KB would be 0, 1, and the next state would be 1, 0. And for the next one, it's going to be 0, 0, 1, 1, and next state would be 1 and 1. And the same way, 0, 0, 0, 0 for JA, KA, JB, and KB. And when all of them are 0, it's going to keep the current state, so it's going to be equal to 1. 0 because A and B were 1, 0. And for the next one, it's going to be 1, 1, 1, 1. And when it's 1, 1, it's going to toggle. So because A and B are 1 and 1, the output will be 0 and 0. And finally, for the last one, it's going to be 1, 0, 0, 0 for the inputs of the flip-flops. And when JA and KA are 1, 0, then it's going to be a set. So the output would be 1. And when it's 0, 0, it's going to be no change. So it's going to be 1. So 1 and 1. Now that we have this, we want to draw its diagram, state diagram for it. And for that, what is our current state? It's 0, 0. And what is the next state we want to go for? Let's say we're going from 0, 0 to 0, 0. What is x? 1. So 0, 0 to 0, 0, x is what? 1. Now, if we want to go from 0, 0 to, let's say, 0, 1, what is x going to be? 0. So 0, 0 to 0, 1. Now, if I want to go from 0, 0, 1 to 1, 0, what is x? Or to 1, 1, what is x? X is going to be 0. So I'm going from 0, 1 to 1, 1. 0, 1 to 1, 1. X is 0. Now going from 0, 1 to, if I draw another one, 1, 0. So 0, 1 to 1, 0, x is 1. So 0, 1 to 1, 0, x is 1. Now, if I want to go from 1, 0 to 1, 1, 1, 0 to 1, 1, what is x? 0. So 1, 0 to 1, 1, x. 1, 0 to 1, 0, x is 1 to itself. And 1, 0 to 1, 1, x is 0. Now, what's left? We want to go from 1, 1 to 0, 0. If I want to go from 1, 1 to 0, 0, what is x? It's 0. And if I want to go from 1, 1 to 1, 1, x is what? 1. Now, this is the diagram for this particular system. Now, let's study another one using a T flip-flop. So for this particular T flip-flop, the input of the first one, the flip-flop A, is connected to an AND gate, and its other input is connected to the output of the second flip-flop. Now for a T flip-flop, just going to bring up the reminder for a T flip-flop. Now for a T flip-flop, as you may remember, if the input is 0, QT plus 1 is going to be equal to QT. In other words, it's not going to change as well. It's called a transfer flip-flop as well sometimes. And if T is equal to 1, the output would be toggle, or it's going to be inverted. Okay, now let's go back to the T flip-flop. Now, if we would start with writing the outputs in relation to their inputs. So TA is going to be equal to BX, because again, one of the inputs of the AND gate is connected to B. The other one is connected to X, so TA would be BX. And what is TB? TB is directly connected to X, so TB would be equal to X. Now, what is A equal to, or Y equal to? It's going to be A and B. And what is A and B? A is going to be equal to T Q prime plus T prime Q. In other words, if we want to write that, it's going to be AB prime plus AX prime plus A prime BX. And BT in the same way is going to be T Q prime plus T prime Q. By the way, for a T flip-flop, T is equal to, A is equal to T, X or with Q. And if I want to expand it, it's going to be T Q prime plus T prime Q. Okay, this is the equation for the output of a T flip-flop. Now, if we simplify the second one, it's going to be X or with B, and the first one is going to be AB prime plus A X prime plus A prime BX. And where did we get this? Again, we will replace TA with BX, so TA would be BX, and so on. And Q prime, as mentioned, is going to be equal to the output, so it's going to be equal to T at that time. Now, if we write down the table, if the present states A and B are 0, 0, and X is 0, what would the next states A and B be? So A is 0, B and 0. Now B is connected to this, so this would be 0, and X is 0. So 0 and 0 and would be what? 0. What happens if T is 0? What happens to the output? It will remain the same. And what is TB here? That is also connected to X, so it's 0, so it's going to remain the same. So both of them would be, TA and TB would be 0, 0. What would Y be? It's going to be 0 and with 0 gives us what? 0. And A and B would not change because T was 0, so it's going to give us 0, 0 as well. Now for the next one, A and B are 0 and 0, but X is 1. So if X is 1, let me do it with a different color. So if X is 1, T is connected to X, TB, so TB would be 1. And initially B was 0. So 0 and with 1 gives us what? 0. So TA would be 0. Okay. And by the way, this first one, Y was 0. Now, if B is 0 and A is 0, for the second one, so T is 1. When T is 1, what happens to B? It toggles. It becomes what? 1. So B would become 1. When it's 0, what happens to A? It remains the same. So it's going to be 0. Okay, so 0 and 1, again, Y would give us 0. So 0, 1 for TA and TB, and 0, 1 for A and B. Now for the third row, A is 0, B is 1, and X is 0. So if X is 0, this output of the AND gate would be 0, regardless of the other one, which is 1. And this is equal to 0. 0 and 0, what happens to the outputs? 0 and 0. The outputs will remain the same that it was in the previous stage. So it's going to be 0 and 1. Okay. And 0 and 1, again, the output of Y gives us 0. So 0, 0, and A and B are going to be 0 and 1. Now for the next one, can you help me with the next one? A and B are 0 and 1, and X is 1. So 0, 1, and X is 1. What is TA? What is TA? Louder, please. 1, thank you so much. What is TB? TB is also 1. What happens if TA and TB are 1 and 1? Both of them will be what? Toggled. So the next stage would be 1 and 0. Am I correct? And since both of them, A is 1 and B now is 0, again, Y would be 0. So 1 and 1 and 1 and 0. Now, what about the next row? 1, 0, and 0. So A is 1, B is 0, and X is 0. So 0 multiplied by anything gives us 0, and this 0 is again 0. Yes. So TA and TB are both 0. Now, if they are 0, what happens to A and B? They remain the same, so it's going to be 1 and 0. And 1 times 0, again, Y would be 0. Now, the next row. So 1, 0, 0, 0. And the next stage, we have a next row, we have A is 1, B is 0, and the X is 1. So A is 1, B is 0, and X is 1. Now 1 and with 0 gives us 0, and 1 moves to the TA. So TB. TA is 0, and TB is 1. Now, if TA is 0, what happens to its output? It's still 1. What happens to the output when TB is 0? Yes, B becomes 1, or the 0 becomes 1. So it will be 1, 1, 0, 0. Now, what about the next one? A and B are both 1, and X is 0. Again, because one of the inputs of the AND gate is 0, we don't care about the other input. It's going to be 0 anyway. So TA would be 0, and TB is also 0. When both of them are 0, what happens to the inputs? Remain the same. So it's going to be 1, 1, 0, 0. What about the last one? I want you to solve this one. So A and B are 1 and 1, and X is 1. What is TA? Thank you. It's 1. And what is TB? 1. If both of them are 1, what happens to the next stage of A and B? Both toggle, so it's going to be 0 and 0. It's going to be 1, 1, and those two would be 0 and 0. Now, the output of Y, for the first one, A times B, next stage is going to be 0. I did it. Second one, 0, Y, 0, 0. It's just going to be 1 and 1 here. So because we had A and B were 1 and 0, it's just going to be 1, 1 when A and B are 1 and 1. Now, we have the input, we have the output, X and Y. We have the stages. We are going from 0, 0 to 0, 0. If I go from 0 to 0 to 0, 0, what is my input? 0. What is my output? So if I want to go from 0, 0 to 0, 0, the input is 0, the output is 0. Again, this is the input. This is the output. Okay. So X and Y. X and Y. Now for the next one, I'm going from 0, 0 to 0, 1. 0, 0 to 0, 1. What is my input? So I'm going from 0, 0 to 0, 1. My input is 1. My output is 0. So input of 1, output of 0. We're going to 0. Now we're going from 0, 1 to again 0, 1. If I want to go from 0, 1 to 0, 1, what is my input? What is my output? 0. The next one, I'm going from 0, 1 to 1, 0. So let's put 1, 0 here. So 0, 1 to 1, 0. Or we can put 1, 0 here or there, doesn't make a lot of difference. Let's do this one. So 0, 1 to 1, 0. X is 1 and Y is 0. So X 1 and Y 0. Now I want to go from 1, 0 to 1, 1. Again, I'm sorry, 1, 0 to 1, 0 first. 1, 0 to 1, 0, x is 0, and y is 0. So it's going to be 0 and 0. Now I want to go from 1, 0 to 1, 1. X is 1 and y is 0. X is 1 and y is 0. I want to go to 1, 1. Again, I want to go from 1, 1 to 1, 1. X is 0 and y is 1. And finally, I want to go from 1, 1 to 1, 0. X is 1 and y is 1. It's better to show it. So 1, 0 to 1, 0 is going to be 0 and 0. 1, 0 to 1, 1 it's going to be 1, 0. And 1, 1 to 0, 0. 1, 1 to 1, 1 is 0 and 1. And 1, 1 to 0, 0 is going to be 1. Now this is the state diagram for this particular system. Okay. Now, for example, in an FE exam or your exam, you're usually given a circuit like this, and they ask which one is the state diagram for this circuit. Okay, so the steps are this. First, you will write the Boolean function for each of the outputs. Y, here we have an output Y, so you will write it down, and A and B. Then you would draw the truth table for it, and from the truth table you get to the diagram. Sometimes, and I'll show you later on, that this diagram you can actually simplify the whole system. So the Mealy and Moore models, the Mealy and Moore models are the models that we can represent, again, these sequential circuits like that. So in the Mealy model, the outputs are function of both the present state and inputs. The output may change if the inputs change during the clock pause period. The outputs may have momentarily false values unless the inputs are synchronized with the clock. And in the Moore model, the outputs are function of the present state only. The outputs are synchronized with the clocks. I think it's enough up to this point for today. Again, we're going to have our second exam next week, and I've posted an announcement on Canvas. You can check that on. And before that, we're going to have a review session. If you have any questions, just please let me know. Just email me about any questions. And the exam is going to be the same format as your first exam. Thank you so much, and I will see you next week.